Alright, so we got a plane that is flying at a speed of 250 miles per hour at a bearing of south 30 degrees east. There's also a wind that is blowing from west to east at a speed of 30 miles per hour. So the question is to find the ground speed of the plane and the plane's true course, right? And the idea here is that because there is a wind, right, that is going to affect the overall speed, but also the bearing or the heading of the plane, right? So let's just draw the vectors and see what's going on. Okay. So south 30 degrees east. Okay. So remember, you got to know how to understand the heading here, right? So from south, right? So this is the south. And from the south line here, we want to rotate 30 degrees to the east, right? So this plane, what this plane is doing is it is going at a bearing of this direction right here, right? And this angle here, right, this is 30 degrees right there. Okay, so that is the bearing or the direction of the plane. Okay, the magnitude of this plane, right? The magnitude of this plane is 250 or 250. Okay, and we can find this angle certainly, right? This angle right here, we can find that. Okay, because we know that we go 270 right here plus this extra 30. So what would be the vector given by the plane here, right? We'll call this u. Okay, so u in this case should equal then 250 cosine of 300 degrees, and we'll call that the I vector, plus 250 times the sine of 300, and we'll call that the j component, right? Okay. So we know what cosine of 300 degrees is, right? That's 1/2. So this u vector, which is given by the plane, right, should be 125i plus, or in this case it's going to be minus, right, minus 125 radical 3j. Okay, so this is the vector given by the plane. Okay, so we go 125 this way and 125 radical 3 down this way. Okay, this is where the plane is. Okay, but there's also a wind, right? Okay, so the wind is blowing from west to east at a speed of 30 miles per hour. So we can draw that right here, right? This wind is going this direction, right? 30 miles per hour. Okay. So let's call this vector v. Okay, so this vector v, which is the wind, should be what? 30i, or 30i, right? Plus 0j, right? There is no vertical component of this vector. It blows straight from left to right. So what does that mean then? What does that mean? It means that the plane, right, the plane's true course is not 300 degrees, right? It's going to be this guy right here, okay? So we want to find the magnitude of this red vector, okay, which is the sum of the plane and the wind, okay? And then we also want to find the new angle given by this vector in red, okay? So how are we going to do that? Well, we know, let's call this vector w, right, which is the ground speed of the plane. Okay, so this should be then the plane, okay, plus the wind. Okay. And in order to add vectors together, we just add the corresponding components, right? So that's why we always write out the components, right? Anytime you have a vector, okay, you want to know three things, right? You want to know the magnitude, you want to know the angle or the bearing, but you also want to know the components. Okay, so we've written them all out already, right? So what is the horizontal component? We got 125 plus 30, right? So this vector w is going to be 155i. Okay? And then when we add the j components together, right? Negative 125 radical 3 plus 0, that's actually just going to give us minus 125 radical 3j. Okay? So really, that is going to be this vector in red, right? We're going to go 155 as a horizontal component, and then 125 radical 3 down this way, okay? So we can see that due to the effect of the wind, right, it pushes the plane a little bit further east, okay, and also increases the ground speed, right? The effect of the wind will increase the speed of the plane. All right, so this is the new vector, right? Adding the plane's components plus the component of the wind, okay? So now we should be able to find the magnitude, right? The magnitude is the ground speed, okay? So we're just going to find the magnitude of W now, right, which is the plane. So it's just going to be the square root of 155 squared plus negative 125 radical 3 squared. Okay. So once you enter this in, we should get 266.27 miles per hour, right? I'm just going to round that to 2 decimal places right there. So we see that, notice the original speed of the plane was 250, but due to the effects of the wind, right? Due to the effects of the wind, okay, the ground speed of the plane is going to be 266.27. Well, how are we going to find this angle? How are we going to find this angle? Well, we just use trig for that, right? We know that this is a right triangle, so we should be able to use tangent in this case, right? So tangent of theta, okay, should equal b over a. So theta is going to be the inverse tangent of negative 125 radical 3 divided by 155. Okay, so when you do the 125 radical 3 divided by 155. Now, when you do this, okay, you'll see your calculator, I guess, right? Your calculator is going to tell you negative 54.4 degrees, which is okay, right? But we should give the answer as a positive angle, so we'll just add 360 to this to get the reference angle, right? So we're going to end up with 305.6 degrees. So once again, because of the effect of the wind, right? The wind is blowing straight east, right? Okay, so because of the effect of the wind, it increases the ground speed of the plane, okay, and it also pushes the heading of the plane a little bit further east.